Hi everyone. This is the last exercise for chapter 16 on the normal distribution. It's the normal approximation of the binomial distribution. So let's look at when you start with a just various distributions. So here you have a pattern when you have it's starting with the binomial. So n will be your number of trials and p will be your probability of success. As we move to the right, the probability of success is increasing. In the middle we have a even probability of 1 over 2. And vertically we start with a low number of trials, so here n equals 10, and as you go downwards you increase the number of trials. So as we go downwards, first no we start across, so we can see the skewness of the binomial distribution, something to keep in mind. The one within the center, it's fairly symmetrical, so it's already similar to a normal distribution. As you move down and increase the number of trials, you can see that it looks very similar to a bell-shaped curve. And independently of the probability of success, here you have 0.2 and 0.8. As you go downwards, you increase the number of trials, they also converge towards a normal distribution. As it converges towards a normal distribution, then we can apply all the rules that we know, the empirical rule, the standard normalization, and the symmetric properties. So as I said before, if n is large enough and p is not too close to 0 and 1, you don't want to be extreme. As the skewedness get extreme, it will take a very large amount of n, or it might not be possible to approximate it. So most of the cases will be not as close to those extremes. Then we can use this approximation, and what we do is the mean will be approximated and the standard deviation using those respective formulas. Okay, so let's see one examples. So with this example, you will have your binomial distribution, you have your n and p, and you need to determine the probability between that range. So first you determine your random variable, then you assume to be a binomial random variable with the n and p values. N being very large, you can then approximate to a normal distribution with the mean and the standard deviation using those formulas. You substitute the values and approximate, or calculate I should say. Then we can write the probability with the interval. Next is you standardize it, and then what you do is you use the Cas function and determine its probability, and that's the answer to this question. All right, and yeah, that was short and that was it. So see you later.